Welcome to the deep dive. Today, we're really going to get into something foundational to, well, pretty much everything digital these days, VMware Cloud Foundation, or VCF. Think of like getting a backstage pass to see how these huge, resilient, really smart enterprise cloud environments get built. We've got some fascinating insights actually sourced from practice questions for pretty high-level VMware certification. But don't worry, this isn't an exam prep session. Our goal is to kind of reverse engineer the core ideas from these questions. We want to pull out the really important bits so you, listening, can grasp the clever thinking and, honestly, the critical nature of how these cloud platforms are put together and run. You definitely don't need to be an IT architect to get this stuff. So, yeah, expect some aha moments, hopefully, and a clearer view of how these things are designed, kept safe, and made bigger when needed. It's kind of your shortcut to being in the know.
That sounds like a great way to approach it. These exam questions, they often pack years of real-world experience and tough design choices into neat little scenarios. It gives us a really focused look at the features that make the biggest difference and, why they actually matter day to day.
Okay, so let's start with the absolute basics. When you're building, any serious digital setup, two things jump out immediately. Resilience, like can it survive a real disaster?
Yeah.
And expandability, can it actually grow with the business?
Absolutely. Those are, well, they're non-negotiable for any serious enterprise today. You just can't run a modern business on systems that might, vanish if there's a major outage or that choke when things get busy. So let's look at how VCF handles that core stability.
Right, so let's imagine something really bad happens. A whole data center gets knocked offline. Maybe a flood, huge power failure, something that takes out the entire building. What's the VCF feature that kicks in to save the data and keep everything running, ideally so smoothly that end users don't even notice?
That's where the vSec stretched cluster is absolutely key. It's designed specifically for that kind of site-level protection. What it does, essentially, is it replicates your data continuously across two physically separate sites. So you might have one site in one city and another, say, 100 miles away in a different one, and the data is kept in sync between them.
Okay, so like a mirror image.
Pretty much, yeah. But the really powerful part is the automatic failover. If that first site suddenly goes dark, the system automatically switches operations over to the second site. This is what provides that business continuity, that disaster recovery right within VCF. So yeah, if one site is gone, your services just keep running, often without any IT person needing to, press a button in the middle of the night.
That really is an eye-opener. The idea that a whole physical location can just disappear and, your banking app or your work tools just carry on. But, I mean, how automatic is it really? Is it totally hands-off, or are there things architects really worry about, like, say, the connection between those two mirrored sites?
Oh, that's a great question. You've hit on something crucial. While the failover process itself is designed to be automatic for the applications and data, the design of that network link between the sites is, well, everything. Architects absolutely obsess over this. You need really low latency, meaning very little delay, and tons of bandwidth between those two locations. Because if that connection isn't super solid, that automatic failover might stumble, So it's automatic when it happens, but it relies on really careful planning beforehand.
Right, meticulous planning.
Yeah.
Got it. Okay, so we've got our resilient foundation, these twin sites backing each other up. But what happens when things go well and we need more power, more compute muscle in our VCF workload domain? What's a really key thing you have to check for with those new ESXi hosts, those servers you're adding?
Yeah, this is one of those details that can really trip people up if they're not careful. When you expand a cluster, all the ESXi hosts must use CPU's processors from the same family. It's a fundamental compatibility thing. Think of it like trying to build a high-performance rowing team. You want all the rowers using the same type of oars, working perfectly in sync.
Okay, same CPU family. But why exactly? I mean, if one processor is just a slightly newer model, wouldn't they still mostly work okay? What's the big problem it avoids?
Well, the big problem is that it breaks critical functions. The main reason is compatibility for features like vMotion. That's the tech allowing you to move running virtual machines live applications between physical servers with zero downtime for the user.
The live migration thing.
Exactly, and other workload migrations too. If you mix CPU families, even slightly different ones, you can hit incompatibilities that just stop vMotion cold. Imagine trying to instantly shift a running video stream from one server to another, but the new server's brain, its CPU, speaks a slightly different dialect. Things stutter, or worse, they crash. So keeping the same CPU family ensures those operations are totally seamless, and you maintain that flexibility VCF is known for.
Okay, that makes perfect sense. Seamless operations are key. So we have our resilient compute, we know how to expand it. But how does everything actually talk to each other? And how does it talk to the outside world? And importantly, how do you manage this potentially huge, complex environment?
Right. This is where VCF's integrated networking and management pieces really come into their own. It's designed for both, high-speed communication and giving you that central control point.
Let's talk about that communication first, specifically this north-south traffic idea. Can you just quickly break that down? What does that mean for someone not deep in networking?
Sure thing. North-south traffic is basically data moving between your internal VCF environment and anything outside it. So traffic going out to the public internet or coming in from users or maybe connecting to another traditional data center. It's the in and out traffic for your cloud.
Gotcha. In and out. Okay. So for handling that kind of traffic, well, what's a critical design point for the NSX Edge cluster? NSX being the network virtualization piece, right?
Exactly. NSX is VMware's software-defined networking, and the NSX Edge cluster is like the main internet gateway for your VCF environment. A really critical design point is ensuring it has sufficient uplinks connected to the physical network, what we sometimes call the physical fabric.
Uplink, so enough connections to the actual wires.
Basically, yeah. Think of it like highway on-ramps and off-ramps for your cloud city. These uplinks are the high-speed connections from the NSX edge nodes to your physical network switches. And why it's so crucial is simple: avoiding traffic jams, bottlenecks. This cluster handles all that traffic going in and out. If you don't give it enough lanes, enough bandwidth through those uplinks, everything slows down. User experience suffers, application responses lag. It's fundamental for performance.
Right, got to keep the data superhighway flowing freely, no gridlock.
Hmm.
Okay, so we build it, we connect it, but how do we keep it running well and maybe even see problems coming? What's the big value add of putting VMware area operations into the VCF mix? Is like the cloud's, I don't know, control tower or crystal ball?
Crystal ball is a good way to put it, actually. VMware Area Operations, when you integrate it, provides really advanced capacity and performance analytics. Its main value is giving you deep, real-time visibility into how your entire VCF environment is doing, how it's using resources, compute, storage, network, everything.
So it's more than just dashboards with flashing lights.
Yeah. Oh, much more. It does comprehensive monitoring, yes, but also capacity planning, figuring out when you'll need more resources before you run out, and performance optimization. It helps admins proactively manage things, spot trends, and catch potential issues early, often before they even impact users. What's really cool is it shifts things from being reactive, fixing things after they break, to being proactive, predicting and preventing problems by understanding those usage patterns. It's like that city planner knowing where the next traffic jam will be before it happens.
So without something like area operations, IT teams are kind of just fighting fires, reacting rather than planning.
Largely, yes. Or at least it's much harder to be strategic. You're often finding out about a capacity issue only when users start complaining that things are slow. Area operations lets you make decisions based on data, turning that reactive firefighting into, well, proactive management. Much better.
Okay, that's huge. Now, with all these parts, compute, storage, networking, area doing the monitoring, who actually conducts the orchestra? Who handles all the updates, the patching, the deployment across this whole complex VCF stack? Who's the main operator?
That absolutely crucial role belongs to the SDDC manager. It really is the heart of lifecycle management within VMware Cloud Foundation. Its main job is to automate all that stuff, deploying new components, patching existing ones, managing upgrades across the entire infrastructure stack. Compute, storage, network resources, SDDC manager coordinates it all.
Automation. So it saves IT teams a ton of manual work.
A massive amount, yes. But it's not just about saving time, though that's significant. It's also about reducing human error. Manually patching dozens or hundreds of interconnected components is incredibly complex and, frankly, prone to mistakes. SDDC Manager ensures consistency and reliability. It keeps your cloud environment secure, up-to-date, and compliant without needing people to manually touch every single piece.
So it basically prevents those, oops, missed a server moments during late-night patching sessions. That sounds invaluable. But does that level of automation ever feel like losing control for the IT folks? Or is it just seen as essential complexity management?
It's overwhelmingly seen as essential. The sheer scale and interconnectedness make manual management almost impossible, or at least incredibly risky and inefficient. SDDC Manager provides guardrails and ensures things are done in the right order according to VMware's validated designs. It actually enables a better control by ensuring consistency and freeing up IT staff for more strategic tasks rather than just repetitive patching. It's smart automation, not just blind automation.
Okay, smart automation. Makes sense.
hmm
So now we know how to build it, connect it, manage it, keep it updated. Let's talk about protecting it, moving things around. Security and mobility.
Yeah, absolutely critical pieces. You need to protect the valuable data and applications inside, and you need the flexibility to move workloads where they need to be. That's a huge part of the cloud promise, right?
Definitely. So security first. Let's talk access, the front door. When you're designing how administrators log in to manage VCF, what's the best practice? How do you give out the keys securely?
The standard best practice, really for any enterprise system, is to integrate VCF with centralized authentication systems. Things like Active Directory, which many organizations use, or other LD app-based systems.
Called EIP, that's like a corporate phone book for computers, right?
Kind of, yeah. It's a protocol for accessing directory information services. Active Directory is Microsoft's implementation. The point is, instead of creating separate usernames and passwords on every single VCF component, which would be a nightmare to manage and secure, you connect it to your organization's central identity system. This gives you secure, auditable, role-based access control. You define roles like cloud admin or network admin in one place, assign users to those roles, and VCF respects those permissions. It's far more secure and manageable than local accounts.
Right. One central place to manage who gets in and what they can do. Much cleaner. Okay, but once someone is authorized, or once applications are running, how do you prevent problems from spreading within the cloud? How do you protect, say, the finance application from a potential issue in the web server farm, even if they're in the same VCF environment? How do you build those internal walls?
That's where microsegmentation comes in, and NSX provides powerful tools for this, specifically things like security tags with dynamic groups. Instead of just having a big firewall at the edge of your data center, microsegmentation lets you create fine-grained security policies around individual applications or groups of virtual machines.
So like security zones inside the cloud.
Yeah, exactly. And the dynamic groups part is really cool. NSX can automatically group VMs based on criteria you set, maybe based on their name or the OS they're running, or a specific tag you assign, like production finance. Then you apply security policies to those dynamic groups. So maybe only VMs tagged finance app server can talk to VMs tagged finance database. This creates these tiny isolated segments automatically. If something bad happens to one web server, it can't easily spread laterally to, say, your critical database server because the policy blocks that traffic. It contains threats.
So it's like automatic quarantine zones based
Right.
on rules. That's much more granular than just a perimeter wall. Very clever. Okay, security covered. Now mobility. What if you need to move workloads, not just between servers in one location using vMotion, but between entirely different VCF instances, maybe even across continents? Which VMware tech makes that happen? You mentioned something called HCX.
Yes, VMware HCX, which stands for Hybrid Cloud Extension. It's specifically designed for that kind of large-scale workload migration and mobility between different environments, could be between two VCF data centers, or even between VCF and a public cloud.
Okay, HCX. And you mentioned two key services within HCX that are crucial for moving workloads between VCF instances.
Right. For those big moves, especially over long distances, two HCX services are particularly important. One, optimization and network extension. One, optimization tackles the performance problem. Moving terabytes of data over a wide area network, like across the country or overseas, can be really slow. One, optimization uses various techniques like data deduplication and compression to speed that up significantly.
Okay, so it makes it move faster. What about network extension?
Network extension is arguably even more crucial for seamlessness. It allows you to effectively stretch your network segments between the two VCF sites. This means your virtual machines can keep their existing IP addresses and network configurations even after they've been migrated to the new VCF instance.
Wow, okay, so the applications don't even realize they've moved to a different network in a different place.
Exactly. From the application's perspective, its network environment looks the same. This avoids potentially complex and time-consuming IP address changes and reconfiguration, which is a huge benefit for large-scale migrations, disaster recovery scenarios, or data center consolidations. It enables that true hybrid cloud mobility.
That's incredible. True seamless mobility across sites. Okay, we've covered a ton of amazing tech: resilience, expansion, networking, management, security, mobility. But let's step back. How does an architect actually design one of these complex VCF solutions? It can't just be about knowing the features, right? There must be a methodology, a way of thinking.
You're absolutely right. It's not just about listing features. There's a whole design methodology involved, especially within the VMware framework. It's about understanding the why before the how. It defines how you gather information, make decisions, and balance different factors, especially when you're dealing with what the customer needs versus the limitations you might face.
Okay, needs versus limitations. That sounds important. Let's dig into that. This seems like a really key distinction. So imagine a customer absolutely insists on using their existing old tape-based backup system for protecting workloads in their new VCF environment. Maybe they have compliance reasons or just a huge investment they don't want to ditch. How should an architect classify that specific input from the customer? Is it just a preference or something more concrete?
Within that VMware design methodology we talked about, if the customer insists on it, that's classified as a business requirement. A business requirement represents something the customer has identified as a definite need for the solution. It has to be included, even if, from a purely technical standpoint, you might think there are better or newer ways to do it. It's driven by their business needs or policies.
Okay, so requirement means must-have, driven by the business. Got it. But then, what if that same customer also says, oh, and by the way, our budget for any new backup hardware or software is practically zero? How does that fit into the design puzzle?
Okay, now that is what we classify as a constraint. A constraint is different from a requirement. A constraint is a limitation or restriction that limits your design choices. It narrows down the possible ways you can build the solution. Common constraints are things like budget, project timelines, existing infrastructure that cannot be changed, specific hardware compatibility lists, or regulatory rules you absolutely have to follow. So in your example, the customer requires tape backup. That's the need. But they have a constraint of a limited budget for new gear. That's the restriction. Understanding this difference, what's a requirement versus what's a constraint, is absolutely fundamental for an architect. You have to design a solution that meets all the requirements while staying within all the constraints. It's a balancing act.
That's a really clear and practical distinction. So the architect's job isn't just technical wizardry. It's also about understanding the business, managing expectations, and finding creative solutions within those boundaries, needs versus limits.
Thank you so much for joining us on this deep dive today. Keep asking questions, stay curious, because as we've definitely seen, there's always more to learn about the amazing technology that shapes our lives.